Good morning, students. In the previous video session, you have gone through Newton's second law and Newton's third law, and today we can see some of the discussion on these Newton's laws. The first discussion is we know the equation F is equal to ma. F equal to ma, and this equation F is equal to ma equation is a vector equation. So like this, the Newton laws are vector laws, we can tell, because it is a vector equation. You know that both sides it contain some vector quantities, and you know this equation also it contains some scalar equation also. So three scalar equations together, it is what one vector equation. We know this thing while studying in the vector and scalar. Maybe you have known that if you are multiplying two vector equation, we will get one scalar equation. So that is what here the three scalar equations are equivalent to form what this vector equation F is equal to ma. And in Cartesian coordinate system, we know that x coordinate, y coordinate and z coordinate system, three coordinate system x, y and z. So if you are taking this equation in terms of this Cartesian coordinate system, we can write this equation left side f x I, you can write I unit vector plus f y j unit vector plus f z k unit vector equal to, you can write m a x I unit vector plus m a y j unit vector plus m a z j ma z k unit vector. So fx is equal to max fxi plus fyj plus fzk is equal to max plus may plus maz, and this ijk indicating this coordinate system unit vector direction. So if we are comparing the both side, left side is this one and right side is this one. If we are comparing this left side and right side, we will get an equation fx equal to max, fy equal to may, fz equal to maz. Actually this is what the acceleration along the x direction depends only on the component of force acting along x direction. There is a force acting along x direction, so that acceleration is depending upon in the same x direction. Here you can see the acceleration along y direction and depending upon the component of force acting in y direction. And here you can see what the force which is acting on z direction, so that the acceleration depending upon what this z direction. This is what the first point. So what is first point? Newton laws or vector laws. The equation F is equal to ma is a vector equation, and essentially it is equal to three scalar equation. So you can write this equation in a Cartesian coordinate system. How you can write fxi plus fyj plus fz k unit vector is equal to maxi unit vector plus mayj unit vector plus maz k unit vector. So that if we are comparing the both left side and right side, we will get fx equal to max, fy is equal to may and f is equal to maz. Now the second point is you can write this thing. Second point is f of t is equal to ma of t. What is this F of t is equal to ma of t. This is nothing. The acceleration, here you see the acceleration experienced by a body at time t depends upon the force which act on the body at that instant of time. It is nothing. It is saying about the acceleration of the object does not depending upon the previous history of the force. If you are saying the example, actually here it is saying the acceleration on that object which is not depending upon the previous time. At that instant of time, how the force, depending upon the force, the acceleration will be. That is what the second point. You can say that example also, one very nice example you can say is cricket ball. While playing the cricket, the fast bowlers are there, spin bowlers are there. Once they release the ball, we cannot tell that on acceleration of that ball by using their previous history, where they thrown. That is what the previous history. So, because you see, when they release the ball from their hand, it experiencing what? Gravitational force, air resistance, air frictional force. So what will happen? This acceleration of the ball. The acceleration of the ball is independent of what? How the ball was bowled. Once the ball is released from their hand, then it is independent of what? How the ball was bowled. That is what this second point of Newton's discussion. Acceleration, anytime, acceleration of any object, it is not depending upon the previous history of the force. That is what the second point you can tell. The acceleration experienced by a body at time t depends upon the force which act on the body at that instant of time. Once you have thrown the ball, it is thrown. Then the acceleration of the ball, it is depending upon the gravitational force and the air frictional force. So that is what here it is saying, whether it is a fast bowler or spin bowlers, once he thrown the ball to the batsman, once he leaves the ball from his hand, what will happen? That ball is experiencing only the gravitational force and the air frictional force only. So that is what second point. And the third point is direction of force. Direction of a force may be different from the direction of motion. So direction of a force may be different from the direction of a motion. Here I will tell you some of the cases you can go through. First case is force and motion are in the same direction. I will show you that. You see, this is what the third point. The direction of a force may be different from the direction of motion. The first case is a force and motion in the same direction. You can see this apple tree. Apples are here. From this each apple there is a downward force which is acting. Once these apples is fall, then what will happen? It velocity also in the same direction of force. So that is what the first point. You see, assume that one apple is there. This is not apple. Okay. One apple is there. When it is on the tree, there is a downward force which is acting on this apple, gravitational force. Any object is there, gravitational force is acting downward. Once this apple is falls from the tree, it experiences a downward force, isn't it? Also, the velocity of this object also downward direction only. That is what both direction of motion of the apple and that of the force are in the same direction. Force and motion in the same direction. Direction of motion is downward. Force acting on the apple also downward. That is the first case. Force and motion in the same direction. Second case is force and motion in the not in the same direction. So you can see that this diagram you see, earth is there, moon is there. From the moon it is experiencing a force. From the moon to the earth there is a force acting between them. This force is in this direction. But what is the direction of this moon? This direction. So the direction of force is acting in one direction and the direction of motion is in another direction. It is in elliptical orbit, isn't it? So this is what the second case. The direction of force and the direction of motion is in different direction, not in the same direction. That is what the second case. Force and motion not in the same direction. And the third case is force and motion in the opposite direction. You can see this diagram. You see a boy is throwing a ball upward. So when he is throwing the ball upward, velocity of the ball is moving upward. No, the ball is moving upward. So the velocity is upward. Direction of motion is in the upward direction. It will go until some point, then it will come back, isn't it? While it is coming down, what the force which is acting is downward direction. That is what force is in one direction, opposite to the force, what opposite to the velocity, force. So force and velocity are opposite in direction. That is what the third case, force and motion in opposite direction. And the last case is, you know, that zero net force but there is a motion. You can see here one example given from the cloud. No, so from this cloud raindrops are get detached from this cloud. Now you see this cloud experiencing both gravitational force and air drag force. So when this raindrop is detached from this cloud, you see, when this raindrop is detached from, you see, raindrop is falling down. When this raindrop falling down, each raindrop experiencing two forces. What are the two forces? Downward gravitational force it is acting, upward air drag force is acting. So when this raindrop is moving downward, this gravitational force is what? Downward force is getting increasing. When this downward force is getting increased, upward force, air drag force also getting increasing. So when it reaches some point, you can see that both force become zero. Both force what? Cancel. So the net force on this each raindrop is zero. Now you can see that each raindrop moves with a constant velocity and reaching the ground. That is what the third case, zero net force but there is a motion. You see, there is no force. Force becomes zero, gravitational and this becomes zero, and but this raindrop is reaching the ground with a constant velocity. So motion is there, force becomes zero. Okay, that is what the third things, fourth case. And fourth point is, so we have seen 3 points. First point is this one. Second point is about acceleration. Third point is about the direction of force and may be different from direction of motion. For that 3 keys also we have seen. And the fourth case is, assume that a multiple force. One force is acting this direction and another force is acting this direction. This we have learned according to vector law of addition. This A vector, this is B vector. We can find out this C. Okay, C means we can find out by what? using the addition method, vector addition method. So that is what we have seen. So multiple force F1, F2. Assume that many forces acting on a object F1, F2, then F3, etc. up to Fn force is acting on an object. Then the net force, total force is equal to what? F1 plus, F2 plus, F3 plus, etc. up to Fn. If you are adding all these force, we will get the net force. So that is what the fourth point. And the fifth Newton's discussion is, this is the Newton's law, no? Second law, F is equal to ma. And the same thing we can write acceleration, we can use d square r by dt square. We can use a is equal to dv by dt. This is what our formula, av is equal to dv by dt. This is a first derivative form of acceleration, and the same equation we can write d square r by dt square. This is a second derivative form of acceleration, so that you can write this equation f is equal to m into d square r by dt square. Or you can write this is what the fifth point. So the last sixth point is, if no force act on the body, then Newton's second law. Assume that one object is there, there is no force act on that body. So Newton's second law, F is equal to m into dv by dt. This is what Newton's second law, ma only we are writing. So ma only, F is equal to ma is second law, and this only we are writing m into dv by dt. So if there is no force acting on the body, force 0 means what? Ma is equal to, or mv dv by dt is equal to what? 0. This is what? Sixth point. And the last point is, Newton's second law is cause and effect relation. Force is the cause and acceleration is the effect. So according to Newton's second law, the same, F is equal to ma, or you can write F is equal to dp by dt. This equation is cause and effect. You know this thing, cause and effect means, assume that one object is there. Now I am applying a force on this object. So I am applying a force on this object. So this force is the cause, and this it is moving, no? So this acceleration is the effect. That is what the last point. Newton's second law is cause and effect relation. Force is the cause and acceleration is the effect. Another example you can say is, assume that one ball you kept, and you are applying a force on that ball. If the ball moves, means it gives some, it got some acceleration. So because of the force you applied, there is an acceleration. So that is what Newton's second law is effect, cause and effect. Here force is the cause and effect is the what? Acceleration. And this is what about the discussion. And again you see, you can go through this point. The first thing is what? First thing is, this is vector laws, and it contains what? 3 scalar equation, and this equation we are writing in a Cartesian coordinate system, and comparing this we are writing for x direction, y direction and z direction its acceleration. And the second one is what? Acceleration depending upon what? The previous. It does not depending upon the previous time. At that instant, what is the time? That is what? The second point. Acceleration of the object does not depend upon the previous history of the force. And the third point is direction of the force may be different from the direction of the motion. Here three cases we are solving. First case is force and motion in the same direction. Second case is force and motion not in the same direction. Third case is force and motion in opposite direction. Fourth case is zero net force but there is a full motion. And I told about all the example. And the fourth point is multiple forces acting on an object. It gives the result. The net force will give what? The total force. The net force means what? We are adding all the force means we will get the net force. And this fifth point is what? We can write this MA equation in second derivative form, m into d square by r by dt square. This is what the second derivative form of acceleration. This is the first derivative form dv by dt, and again we are differentiating, we will get a d square r by dt square. You know this r means position vector. And the sixth point is what? If there is no force, then what? Newton's second law we will get is equal to 0 we will get. And the last point is what? Newton's second law is cause and effect. Force is the cause and the acceleration is the effect. Based on this, next topic is free body diagram. So you have to learn how to draw this free body diagram. Free body diagram means nothing. Assume that in a table one book is there, like this on diagram, free body diagram. You see here on table one book is there. One book is at rest. So downward what is there? Gravitational force. Upward what is there? Normal force. And we are drawing a free body diagram for this. How we are drawing, you see? Just we are drawing. This is what a free body diagram. This is a book. So on this book, downward acting is gravitational force. Weight is acting downward, mg. W is equal to mg, and upward acting is a normal force. So free body diagram draw. Then we can, I'll show you some examples. You see here, you can see that one mango tree, many apples are there. So downward what is acting? Yeah, earth gravitational force, mg is acting downward. Upward acting tension force. So this one free body diagram, how you can draw? You see mango, downward mg acting, upward tension force is acting. So like this you can draw the free body diagram. For that some conditions are there. The first condition is identify the force acting on the object. Second is represent the object as a point. Third thing, draw the vectors representing the force acting on the object. That is what first thing, we have to identify the forces acting on this object. Second thing, we are representing this object as a point. You see book. Now last thing is drawing the vector. So drawing the vector for what? The forces acting on the object. In this book, upward normal force, downward gravitational force. So I am representing vector, upward and downward. So this is how a free body diagram you can draw. Still example I will show you. Many example we can draw like this. Okay. So any diagram you can draw a example. You can draw a free body diagram like this, and you have to learn how to draw this free body diagram and learn what are the procedure, what are the steps to be followed to draw free body diagram. Identifying the force on the object, represent the object as a point, and draw the vectors representing the forces acting on the object. So my dear students, today we have gone through a 5-mark question. this discussion on Newton's laws. You can note down this thing. And I have marked in Inga. That is enough. It is a 5-mark question. You can just learn this very simple question. This is 7 point only. So here is the 7 point. Okay. Here we are writing that 4 case. It will come. Okay. So this is a 5-mark question. So learn this. Okay, thank you all. Bye bye.